problem 4. And if we're figuring out the individual tube dilutions, right, it's the amount transferred plus the whole amount that you're going to end up, so plus the dilutant, right? So for the first one, it would be a 1, 2, 5 dilution. Everyone understand that rule? That one's pretty straightforward. So most of these for this one are what? 1 to 5, right? Until we get to the last one. Trying to type fast. Okay. Although this isn't a standard dilution someone would do, but, you know, just teaching you dilution. So the last one is 1, 2, 3, right? Okay, so notice there's no A on this sheet because A stays the same, right? That's the first one. But B is a combination of A and B, and how do we combine these two? We multiply, right? So 1 times 1 is 1, and 5 times 5 is 25. And then C is what? It is the combination of A, B, and C. Well, we already know what B is, right? Now we just have to multiply by C, which is by another 5. So 25 times 5 is 125, right?
How did you get B again?
B is a combination of A and B. So 5 times 5 gave us 25. Now, once we have B, we can continue on to C just times by 5, right? So, and I missed my 1. Yeah, there we go. So now for D, right, we're just going to take what C's final dilution is and multiply by D, which is another 5. So help me out, guys, with the math. Who's got their calculator? Okay, 620. Thank you. Oh, 625. I was going to say, I thought it would be a 5. Okay, and then we're going to multiply 5 again, right? So what is 625 times by 5? 3,125. And then what are we multiplying by?
3.
Right, so this 3,000 gets multiplied by 3, 3,125 to be 9,375. And that was the main reason why I did these funky numbers, is to make sure that you're doing it correctly. Okay, so we all good to this step. It's pretty straightforward, right? Okay, now the next step can be kind of confusing. So now we went from a tube, which had these set dilutions that we just figured out, right? And we're going to put it on a plate. But we don't put an entire unit. We don't put an entire mil. That would be too much for the plate, right? Too much fluid on the plate. The standard amount that's taking out is 1/10 of a mil. This means that you have 1/10 less bacteria than if you took an entire mil, right? So we need to multiply by 10, because 1/10, right, is 1/10 in fractions. Okay? Still with me? I have some confused looking faces. Okay. So we have to take into consideration that basically because you're taking such a small amount, you're like doing a dilution. So you need to multiply by 1/10, whatever the dilution factor is of that tube, to figure out what the final dilution is for that plate. Okay? So where did plate G come from? Tube D. What's tube D's dilution? 1/625. But for that plate, we need to add another 0, right? We need to multiply by 10. So for this plate, the actual dilution factor is 6,250, so it's 6,250. For H, it's going to be whatever tube E is that it came from multiplied by 10. So we're adding a 0, right? 3,125, add a 0. I got too many numbers here for some reason. So that's going to be 31,250. I came from F. F was 9375, and I'm adding a 0, right, to take into account only taking a tenth out. So that's 93,750 as the dilution. Which plate is countable? G, right? Because it's in the range of 30 to 300. That's why we couldn't use the other two plates, because they're too few, right? Too few to be statistically accurate. All right, now if we want the concentration of our original culture, we now have all the information we need. We have a colony count, right, that's within range. That's 105. We then times that by what? Well, we diluted that plate to what dilution? 6,250. That's the dilution factor, right? We just take the dilution factor. If this is in lowest terms where we have 1 at the top, we just take what's called the reciprocal, which is the bottom of the fraction, right? So we're going to multiply by 6,250. And that's going to give us our concentration. So that's a difficult, who's got the calculator? You can't do that one in your head, Peter?
625,000 plus
3,025. No, oh. All right, just give me the numbers in order. 656. 250. Okay. All right, and then I'll go back and put in, okay. All right, so it's that, right? And what's our units? CFU per milliliter. What does CFU stand for? Colony forming units. Because we're not counting cells, are we? We're counting colonies, right? And it may have been a single cell, but it may not have been, right? So this number may be low, right? Because it could have been maybe 2 cells that form that colony. And that would give us a greater number if they had been separated from each other. So we would write this in scientific notation. So that would be 6.56 times 10 to the 5th, right? Count back from the decimal point.
So you want it on test?
Yes. Yes, we have to do scientific notation. It's not giving me the option for subscript. There we go. And then, all right, and then always have your units, CFU per milliliter. Should probably have a space there. Okay, now once, this is concentration, this is a titer, right, per milliliter. So once we have that, if you know what your beginning volume is, you can take this concentration, right, and multiply it by the volume. What happens to your volumes? They cancel out. So then we're just left with what? CFUs, total CFUs. So in this case, we're just adding 2 zeros, right? So I could just rewrite this, right, and just change my exponent to a 7. That one was super easy. Okay, so this feels good, right? Let's do one more just to keep us all on the same page. Let's see how quick we can breeze through this one. I'm getting rid of these lines because they just create problems for me. All right, so the first one is what? 1 to the 5th. Everyone agree? All right, and then the next one is 1 to 10. And the next one, 1 to 10. I'm on example 5. It's on the back of your sheet that I handed out to you today. The one that you were just writing on. You with me? Okay. And then the last one Yeah, and Peter will be happy that you see like the volumes in the tubes even look different. Okay, so B is a combination of A and B, so when we multiply those two, 5 times 10 is 50, right? And then C is a combination of A, B, and C, but we already have A and B combined, so now we just have to multiply in C, which is multiplying by 10, so we have 1 over 500. And then multiplying by 10 more, right? Which will give us 5.
So you multiply the C
Yep.
by 10?
C by D to get D,
okay.
right? And then we're going D by E
To get E.
to get E, right? Because if we're just keeping multiplying along, right? But why start all over again when we're already halfway there? Right? So E is going to be 50,000. Please speak up if you don't understand what we're doing. Okay? And then in fact, I want to, I'm going to put a little bit of space. Usually when I get past 3 zeros, I like to write in scientific notation. So in this case, we could do 5 times 10 to the, what? How many zeros are there? 4.
I have a question.
And I will have an answer in 2 seconds. Okay. So this is just another way of writing this one, right? This is not F just yet. I'm going to scoot F over. So that if we are now going to the next one and we're multiplying by 5, we're just multiplying the 2 5s, right? So then we could write it one over 25, right? What the heck is that? Oh, I didn't copy what I wanted to copy. That's okay. I can make it what I want. 4.
I'm going to point out during the smalls and medium balls that the amount of diluent you have in each tube can vary. So the practice problems will have different diluent amounts, but they also, the amount of transfer can change.
Yeah.
So you really have to look at both of those. When you
Yeah.
put in individual.
Yeah, we're keeping it relatively simple. It can get a whole lot more complicated, believe it or not. Okay. Alright, so now lining up a little bit better.
So this one's F.
So this one's F.
1 over
Here, look at
25
I'm gonna insert a box. What's F? Yeah, and to be true scientific notation, you do 2.5 times 10 to the 5th. Yeah, but I just wanted to show that, you know, when you have something in exponents like this and you're multiplying by a number, right, you can just multiply by that first number. And then you could shift it over, like we said, since we ended up with a large number. And if you're multiplying by units of 10, you know, you can just change the exponent. But you can just do it out long form too, right? If you don't, it's just once you get past 3 zeros, you usually lose track of zeros. It's best to write them in exponents. It's easier to see. Okay, so now total tube dilution. So where did G come from? It came from D. This is what D is right here, right? 5 times 10 to the 4th.
That's E.
Is what G is going to be, right? G came, oh, that's E. Thank you. You helped me out. Thank you. Keeping me on my toes. Okay. So, yeah. So it would be 5,000, but since we only took 1/10 of a mil out, we need to add what? Or multiply by 10, right? So in this case, it's going to be 50,000, right? Since D is 5,000, what actually got plated on G is a dilution factor of 50,000 because we only took a tenth of the sample.
So you multiply.
We got to multiply by 10. Yes.
So 750 colonies of one of 50,000. The sample of 1 out of 50,000. In that situation.
A factor of 50,000. Not out of, but a factor of.
Okay.
So multiple of.
So it's 50,000 times
Right.
75. And, okay.
Yeah. Yeah. Okay. So for the next one, H came from E. E is 50,000, right? But it's going to be 500,000. And I'm going to take the, I'm going to have it in my exponent form. Maybe. Alright, so then this is to the 5th. Okay, and then I is going to be what F is, right? But one more factor of 10. So we need to change that to a 5, or even we could do the point and make that 6, right?
So you'd look at like the
So-
individual dilution or?
Yeah, so we're, this one right here, and I'll leave it like this, right? So 25 to the 4th, right, is what the tube is, but we only took a tenth of a mil out, so we need to multiply by a factor of 10 for what is actually the dilution factor for that plate. So notice my exponent went up by 1.
You want to write that as 1
Yeah.
divided by the number.
Oh, I forgot my 1, sorry. Divided by, oh, this thing is stuck in.
So it'll be more.
There we go. 1 over 25 times 10 to the 5th. Yes, thank you. Keen eyes, thank you.
Can you explain that one again? I was catching on that one.
Okay. So, whatever was this, the plate, whatever tube it came from, you have to take into account that tube's final dilution, right? In this case, it's 25 times 10 to the 5th. Because we are only taking a tenth of a mil out, we need to multiply by 10, right? Because our dilution factor is 10 times greater because we only took a tenth of a sample out. A tenth of a mil instead of an entire mil. So we always, in this case, are going to multiply by 10. In this case, since I have it in exponents form, I just add a 10 by increasing the exponent by 1.
So the F one is 4, because you said it was 5.
This one's 4.
I actually think to make it a little more clear, Erica,
Uh-huh.
use parentheses in F and also in H and I. For example, I, where your cursor is in parentheses, 25 times 10 to the 5, parentheses, in parentheses.
Oh, okay. So this is all, so that you know
that's
this
all
is,
denominator.
this is all at the bottom of the fraction.
Correct. It kind of looks the way it was written before, actually would have been.
Right. So, and in fact, I'm just going to erase this too, instead of having the two ways of writing it, and just leave it like that.
Clear, you're looking at the denominator in the scientific notation.
That's going to mess my thing up. Running out of room. Alright. I'm not going to fix the... I'm not doing it right now.
Yeah.
It's driving me
But having said it,
bonkers.
maybe that'll
Yeah.
make it clearer to
We
everyone.
have said it, and you're seeing I'm trying to do it, but
Yeah,
there's too many
yeah.
things preventing me right now. Okay, so moving on. Countable plate. Remember, what's our range? 30 to 300. So which one falls in that range? H. Right? And so that one is 75. So we need that colony count to figure out our concentration. And then whatever that plate is, so that plate H, right, is, do we want just the bottom, 5 times 10 to the 5th, right? So that's going to give us what?
3.75 times 10 to the 6.
3.75 times 10 to the 6th. And our units are CFU per milliliter. And then again, if we know that concentration, right? And we know the volume we started with, our volumes cancel out, so we're just left with CFUs. And in this case, we're multiplying by 100 again, which means we're just adding 2 zeros. So 2 exponents, so it'd be to the 8th.
Can I ask you to go up for a second, Erica? Which is the column we'll play here? Oh, H.
H, 75.
75, so then we look at the total plated dilution for H, and it's 5 times 10 to the 5.
Mm-hmm.
And in your calculation, though, you have 25 times 10 to the 5.
Yeah, I was gonna tell you that.
Thank you.
That's what's throwing me off.
I copied the wrong one.
And then it should be times 10 to the 5, not 10 to the 4.
Okay. Thank you guys. And other than Peter, you guys can speak up, and she said she was about to, so good. I was just trying to go quick.
I couldn't write the last one.
Yeah.
Oh, okay. Yeah, no. Here you go. All right. So, do you guys think you could do your experiment that we did and hand it in to me today? Except you're missing one key bit of information. What was the original volume that I made? Anyone know? Remember?
The body for what?
The actual original volume that I made up and then I distributed to each group.
9 minutes?
It was 5.
Or 5?
It was just 5 milliliters. Right? And remember and think back how it wasn't very cloudy, right? Right? Think about the number you come up with, right? And how it wasn't even that cloudy. How many would be in something that's very cloudy? Okay. So,
Before you go
let
on,
me, huh?
Someone's got a question, and I also have a comment.
Okay.
See what her question is.
On F,
Mm-hmm.
for the denominator, 5 times 10 to the 4th,
No. It's to the 4th. Right? Because I didn't multiply by 10, I multiplied by 5, right? 5 times 5 is 25. So the exponent doesn't get changed here. You understand? Cool.
So the volume was 5 milliliters, so is that after the bacterial culture was added? Or
No, your very first culture, right? The one that says bacterial culture that I started with for our experiment. So on your experiment sheet, it asks you question number 4. What was the total volume of the original culture? It was 5 milliliters.
Okay, so my comment, just because I don't want anyone to be confused, you changed an exponent there from 10 to the 4 to 10 to the 5, and so that means your answers also have to change. It should be 3.75 times 10 to the 7.
Oh, right here, 7?
Yeah.
So that means that the next one is going to be 7. And then therefore this one needs to be a 9.
I think that's all right.
Yeah. Hopefully our math is right now. Well, you know, we could find out by, guess what? I have the answer key here that I did before on Blackboard. You just open that up and check our math. Right? So let's see. Yep. Now we're good. And then look at this one, I didn't do exponents. See how I wrote it all out with all the zeros? That answer key. This is on Blackboard. Oh, sorry. Let me make it bigger. Apologize. This is example 5.
The answer for about the 10 to the 9, you need that because of the
Yeah. So notice 7 here, because it's multiplied by 100, right? This gets changed to a 9 because it's 2 more zeros. And then if it was by 200, right, we'd have to multiply this by 2 as well as add the exponent. So there's different ways that you can manipulate math, right? Do what works for you and what makes sense to you, and stick to that plan.
I'm sorry, but tell us the solutions for F, what would be in science for each
Yep,
Zero.
yep, yep, yep.
Making sure I'm getting
Shouldn't the total plated dilutions for I be like 5 to the power of 10? 5 to the, I mean 5 times 10 to the power of 5.
We'll go back.
You multiply by 10, right?
Let me get to where you're talking about. You're talking about this sheet?
Yeah.
And where are you talking?
Over there.
F?
Yeah.
If you were writing in scientific notation, it would be 2.5 times 10 to the fifth. But this is an accurate way to write something as well. It's just not in scientific notation.
So if you're writing scientific notation,
It's still correct, yes.
That's what
Yeah.
I would ask.
And your final answers definitely need to be in scientific notation when you get to the very end. If you don't do it all throughout, you gotta at least do it at the end.
So if you have,
So notice, like on my answer key that I have posted for you guys on Blackboard, I didn't do any scientific notation in my calculations, right? I didn't do it until the very end. But keeping track of all those zeros can be very difficult, especially when you're handwriting. That's why I always suggest, as soon as you can, put it in exponents at least, maybe even scientific notation. Okay? Is that it for questions? We feel better about this, I hope. Okay, and I recorded this too, so if need be, you can listen to it again. This is a really good one. And let's see.